Welcome to Learning Python with Turtle Lesson 10. In this video, we're going to continue our exploration on how to make a process into a function. We're also going to practice reviewing the process and selecting which pieces of information might be best suited to add as parameters, making the function more flexible. So let's get to it. So we have a small process here. Let's look to see what it does. And to me, this kind of looks like a comet. I'm slowly changing the width of the line being drawn as I go forward a small amount and I turn a little bit. So let's cut this and let's make that into a function so we can repeatedly call this comet. Let's review a little bit of what we already have in our function file. So there's a polygon function which, given the number of sides and the distance, will create you any type shape of any type size. We also have two additional functions, a jump function which will raise the pen, go to that location, and then put the pen down. Again, without these two functions here, the pen up and the pen down, if you were to go to a location, it would draw a line, which, again, in some instances, that might be what you're looking for, but more times than not, then when you want to go to a location, you usually want to go to a location without drawing a line from here to that location. We also have the home function, which is very similar to the jump, except it simply returns you back to the middle, and it also orients you back to the turtle's original heading. Again, we're going to be using this one as our example later in the video. So let's create our function comet, and let's go ahead and paste in that process. Recall that when you paste in some code, you may have to clean up some of the indentation, which is how Python decides which pieces of code are part of your function or for loop. And let's test out that function. Make sure that it works as intended. All right, so we still get the same shape comet, but exactly that. We get the same shape comet every single time. So is there something we can do to this function to make it more flexible? So I think the first thing we can have some fun with is let's allow the comet to accept a color. So that way we can change the color of the comet each time. Let's go ahead and test that out. And so that works. Let's go back through here and let's see what other piece of information. This was a new piece of information that wasn't in the original process. But that's okay. Again, you're the programmer. You get to decide what your functions do, as well as what pieces of information are required by your function. So it'd be kind of nice for us to be able to maybe change the size of the comet. So let's accept a distance similar to the way we did it for the polygons, so we could change the size of the polygons. And let's simply just change that hard number of 10 to distance. And now what we can do is let's make this a little bigger. Let's say a distance of 20. And notice that it produces a much larger line. We could also go the other way. Now you'll notice that because of the fact that the width of the line is being changed regardless with each iteration, this almost feels like a short, stumpy type comet. Again, that's up to you, kind of decide what you do with your function. So let's go back to our function. Let's see what other piece of information we can elect to accept as parameters. So I think the other one would be the amount that we turn with each line. Again, what this is going to do, this is going to allow us to change the curvature of that comet. So let's go through here, and I think we had the original number of 10. Actually, I think it was 8. But that's okay. So you can see here, it feels like it curved a little bit more. We can definitely further emphasize the idea of the curvature by making a larger number. So our function is now very flexible in that we can do a bunch of things with this. And one of the things I want to do is to kind of draw a flower type shape. So at this point, I'm going to do a for loop. Let's say for times in range, and let's say 12. So what I would like to do, and I'm just going to run this as it is as I'm talking, um, is not for it to be a full circle, but for somehow for it, the comets to kind of draw here, then draw here, draw here, draw here, constantly going back to the center, and then slowly turning as the comet's being drawn. So for that, I'm going to use that home command that you saw in our function file, which returns me back to the home. And it also orients me back to the uh, same original angle that the turtle was, which now requires me to turn the turtle. So I'm going to do this as a, I don't say the word, it's function, as a operation of times. Recall that times is a variable that will assume the values from 0 all the way to 11. So if I multiply that by, let's say, 30, when times is 0, this would be 0 times 30, 0. So I wouldn't turn anything. But the next time we go through a loop, the value of times is 1. So that would be 1 times 30. Again, this was discussed in a previous video. I just want to iterate this because, again, it's important to understand this as we, excuse me, as we draw this. And you understand that the reason it's turning the right amount is because of this line. So it has a nice effect, and I would like to now maybe put something else in between it. So what I'm going to do is I'm going to copy this code, go here. Now, obviously, if I put it at the same rotation, it's going to draw blue comets on top of the red ones. That's not going to look very nice. So what I'm going to do is, because I'm turning 30 degrees each time, if I simply add 15, that's going to put me in between the comets. And hopefully now you can appreciate, I mean, this is a nice effect of having these overlapping comets of different colors. And obviously at this point you go even further, add another set of rings and maybe do it by tens. But this is where you channel your inner artist when it comes to how to use your functions. Now I want to tackle one more function with you. And this is one I've already kind of created because I don't want you to get into the mindset that functions always require for loops. They don't. It happens to be that many of our functions, because we like to repeat things and let the computer kind of draw it, they do have loops involved with it. But this one's really simple. We simply just change the size of the pen, change the color, and then draw a circle. Excuse me. So for this, let's just practice what the function is doing. Make this a little bigger. Let me do a bob.speed on this one, so this one might just go 0. All right, so again, you kind of get the rainbow effect, and because I chose an appropriate size for the circles, you don't see any gaps between the circles. So it almost looks like they're getting filled in, but they're really not. Again, you saw as they were being drawn, it's just that the next circle was overlapping on the previous one. But now let's go ahead and run this through a for loop. Let's say maybe 3. And then let's also do a bob dot. Let's do it after we draw the rainbow. Bob dot left of 120. Okay. So again, a very nice effect, just to reinforce the power of a function. So we created a function, rainbow, doesn't have a for loop in it, doesn't have any parameters, but it does encapsulate a process which now we can do something with it, which again, we tend to use for loops a lot because again, it allows the program to repeat a process, but not that it's required. All right, so let's go back to our presentation. Let's review what we've done. So in this video, we had another opportunity to practice making a process into a function. We also had an opportunity to practice reviewing the pieces of information in the process and then selecting which ones would be best suited as parameters. So hopefully you're excited about creating more sophisticated designs using functions, and enjoy.